All right. I got it. All right. This mic's on. Yes. Okay. Cool. Well, this is my first time in Australia, actually, and it's pretty great. And I'll be back. We're having an event next year, but I won't advertise this. I'm not going to tell you when it is or where or anything. So I'm happy to be here at Latency. This talk title is Evolving Cloud Security with Vault, which is kind of funny because this isn't a security talk, and it's also not a Vault talk. So we'll get into what it is in a second. The first thing I want to do is talk very briefly about myself. I am a self-taught programmer. I started at the age of 12, and that's not particularly unique. A lot of people start early. I think a lot of people that start at a young age usually have these common threads of, there's a family member who's an engineer who sort of showed them early programming, or a family computer had a basic manual, or there's a teacher, or something. And in my case, none of these things were true. No one in my family programs. They're historically doctors and not, engineers, and so there was no real reason for me to learn programming. So a lot of people ask me, how did I even figure out what this was when I was 12? And it's funny because it all started with a video game, and it started with this video game. And so I guess I didn't know if people in Australia played this, played this. But yeah, so I actually played this game because of a girl in middle school. And for anyone who either played or didn't play, just as a reminder, you would play this game and get these virtual currency thing, and there would be like a timeout period. It'd be like a 10-minute downtime where you couldn't play again. You had to wait. And so I would sit there and wait. And I would come home after school every day and play this game. And I don't know, this is the only part of the story I don't really remember why, but there was a certain moment where I was like waiting in this downtime and I had nothing else to do on the computer, and I was just like looking at one of these pages on this game, and it just sort of hit me that like a question of, did somebody make this? Like, how does this work? Obviously in my head it was like obvious if someone drew some of this, but like how did you associate the buttons, like the selection buttons with the submit button? Like how did it know these things? I'll be honest that my motivation at the time was to try to cheat it to get more Neo points as quickly as possible, but I was still curious about how this worked. And I remember it really bugged me, and so I actually ended up closing the browser window into something that looked more like this. And this is actually really accurate because it was both Windows 98 and it was my grandfather's computer, who I've never one day in my life ever saw him turn it on. So it was actually like a stock install of Windows 98. And I was sitting there like thinking, and I started clicking around. I'm a fidgety person, so I would just like crazily click the start menu, open and closed, open and closed. Still to this day, if I'm on a Mac, I do the wave over the dock over and over, and I do the zoom thing. But I was fidgeting with the start menu, and then it hit me like, did somebody make this? Like, how could this possibly be created? Like, this is crazy. And so if you recall, during that time, you had to start the internet. And so I started the internet, and I was going through that. There's no way America Online is in Australia, right? That doesn't make any sense. Good. There's sanity. Okay. So yeah, we had this, and I would start the internet, and during this, I was making that like terrible dial-up sound, and then I was thinking like, why would anyone choose this noise? And when the internet came back up, I opened a browser window. It was actually an AOL window at the time, but I opened a browser window, and this was the thing I typed. I typed how to make an exe, because my only concept of computers at the time was that I double-clicked this thing that ended in exe, and I had no idea why that was. And so I Googled this. I recall learning nothing. I don't think the search results were very good, or I had no idea what they were talking about, but I was totally stuck with this. And I started coming home after school every day, still playing the game, trying to impress this girl, but during the 10-minute downtime, also searching for how this worked. And eventually I found BASIC and other stuff, and the rest, as you might say, is history. There's a lot there. The point of this, what I'm getting at, is actually the point of this talk, which is to look into creation, this idea that things are created, because still to this day, this completely boggles my mind. I find it so impressive that everything around us, digital and physical, is created by somebody, right? Like even if you look at the things like the chairs you're sitting in or that latency sign or something, like everything goes back to one or a handful of people that decided that needed to exist for some reason. And from then to being here, it takes usually hundreds or thousands of people to make it a reality. But every single thing in the world is the result of 1, 2, 3 people, and it's just crazy to me. Crazy to me. And so, what I want to talk about in this talk is bringing it back from when I was 12 to today. Is something that I created, which is going to be Vault, and this is why it's not a Vault talk, because I'm not going to talk about what Vault does or an introduction to Vault or any of that. What I want to talk about is what sort of factors led to the creation of Vault, and as we were creating Vault, why did we make it the way we did? And how I view, I guess, the act of creation from my point of view, because this is at least what I always want to know. As I look at things and want to know, like, why did that get made, and why did you choose to do it this way? I think it's interesting. And I think that everybody here, everybody in general, is some sort of creator in your job or at home or in your hobby or something. And I don't know, different perspectives are fun. So that's what I want to talk about today, is the creation of Vault. And so to start, we're going to go back to the year 2014. So this is when Vault was created. But even before that, we needed to talk about before that, because why did we even have the idea? So in 2014, and actually 2013, my co-founder and I, Armand, I thought I put his name here, but I didn't. My co-founder and I were working on Hashicorp's first attempt at a commercial offering. It doesn't exist anymore, but it was our first attempt at a commercial offering. And we were a startup. We were a Silicon Valley-based startup, and so we did crazy things that didn't necessarily make sense. And at the time, the things that we decided to do was do everything cloud first, but not only be cloud first, but choose these patterns and practices that were somewhat crazy. Because remember, this is 2014, so some of this stuff is still very difficult. And in 2014, it was basically impossible, as we would find out, and a lot of other companies would find out. But we tried to build everything with microservices. We chose to be cloud first, which was AWS at the time for us. We wanted to fully automate things to the extent that that was possible. We wanted to push the limits of trying to automate everything. We understood that sometimes that's not worth it and things like that, but we just wanted to test the boundaries. And we wanted to practice this idea of immutable infrastructure, or pets versus cattle, that sort of concept. And recall again, 2014, containers are still super new. VM-based sort of config management is still very, very common, very popular. That's sort of the era. And so we sort of started off working on this, and we discovered pretty quickly a number of problems. Some of the problems that we discovered are things such as provisioning, things such as service discovery and scheduling. None of these things really existed in any real form at the time. And so, again, remember sort of 2013, 2014, things like etcd didn't exist. Kubernetes didn't really exist. None of this stuff was there, and so these were the problems we were running into and experiencing. These would become some of the other products that we made, right? That's all I'm going to mention about those. But the other challenge we ran into was also security. And what's funny is that we anticipated the other 3 problems. The other 3 problems are problems we experienced before at other companies and during my co-founder and I's time in college. But security was the only product we actually have today that we never intended to build. But it was such a huge problem that we were running into that we sort of ended up doing it. And so security, when I say security on its own, I mean security is a whole industry, right? It covers everything from like door locks to secrets management, things like that. So when I talk about security, the 2 things I'm talking about, the things that we were hitting, the challenges we were having, was one of secret management and one of data encryption. So secret management is, people usually get this, it's just like access keys, database credentials, things like that. The challenge we were facing was concretely, how do we get stuff like the database credential from where, the source where we could get an API call and get it into our VM images or safely or online. What was the process by which the secret got onto the machine generally was a challenge we were facing. There were solutions out there. We were using Puppet. There were solutions out there like encrypted Hira and some other stuff, but like when we did like a threat model analysis on it, we couldn't figure out what it actually protected. And so there was just issues in security that we were recognizing. And then the other thing is data encryption, which is, we were having PII information, collecting first name, last name, email, address, things like that, billing information. We were a microservices-based architecture, so there was a lot of request response, east-west internally in the cluster, and some of this had secrets in it. We wanted to log it, we wanted to have that information, but we were afraid of logging it because of all the sensitive information that was involved in that. So even if we encrypted, say, a database, what's the point if all your logs have it anyway? And so we were really struggling with sort of the security stance of how to do this without being embarrassed at some point. And so these were the challenges we had, and this forms sort of the first part of creation, of any sort of creation, which is establishing the problem statement. Because you can't really have a solution without a problem, unless you're a blockchain or something. Yeah, so this is, you need to be solving for something, and this is what we needed to be solving for. And so I think the engineer's first reaction, which is fair, is, cool, we have a problem, let's build a solution. That's probably the wrong thing to do. I bet it's the wrong thing to do. The first thing that we did was search for a solution, because even if you want to build, if you desire to solve that problem, and keep in mind at the moment, we really didn't want to build a security product. We didn't want to get into there. And so we wanted to search for a solution, but even if you want to build, you want to survey to understand sort of what the state of the industry and the space is. So searching for a solution in either case is very important. And there's this idea that like everything has to have been solved already, especially something as obvious as like data encryption has to have been solved already. And so the first part of searching for a solution is establishing the context that you need this to work in. And so the context we were working in is cloud. And this is super important because there's technical requirements and then there's context. Just because it checks the technical boxes doesn't mean it actually works. Like you could find solutions that perhaps solve this, but they shipped you a physical box, right? And for us, that didn't fit our context of being in the cloud, being a startup, having no physical presence. Just that as good as the technology is, it's completely invalidated. It doesn't work for us at all. So the first thing I always do whenever I search for a solution is pair the technical requirements with the properties that we're building for. And in our case, this was cloud. The way I like to describe sort of cloud is breaking it down into this. It's an API-driven environment. I've said before that, I've said in 2014 that things that don't have an API don't exist to me. It's not something I even look at. So it had to be API-driven so that we could automate it, because if it doesn't have an API, you can't automate things. The unreliable nature of cloud. Again, circa 2014, everything would get scheduled for termination all the time. So there was that unreliability. But even to this day, right, you get noisy neighbor problems across CPU, memory, network, right? Like CPUs are relatively slow. Networks are sometimes fast, sometimes slow. Disks are sometimes slow and sometimes like totally slow. And so it's just complete unreliability that this jitter that you don't have in physical environments that you have to deal with. This leads to wanting to distribute. Cloud led to wanting more distributed systems because machines are easier to get. You want to amortize this unreliability. You want to be able to handle it gracefully, et cetera. This sort of pushed this trend upwards. Ephemerality comes with it. When you could create and destroy resources really quickly, you want to be able to have those ephemeral things, not just for billing, just like technical understanding. You want things to not exist if you're not using them. Cloud is a practitioner-led environment, and this is the idea that the people who are making decisions in cloud were the users who were using the software, which is very different from sort of a previous era of thinking where the people who were making decisions were the CIOs and the executives and sort of telling developers what to do. Where there was sort of a shift in cloud where shadow ops was coming up and things like that. And so that was just something to keep in mind about how software was being adopted, was by convincing the user and not convincing the CIO yet. And then no hardware. I mean, I think that's obvious. So then we looked at candidate solutions, and I think the summary of the candidate solutions is that they were very not cloud-friendly, generally. To be more specific, there was a lot of single leader systems. The idea that you have your security challenge solved as long as this is running. If this isn't running, then you're down. And in a single leader system that's very, very difficult to achieve in the cloud. So that sort of invalidated things. The APIs that security systems had at the time were really esoteric. They were not made for the idea that applications would really integrate with them. It was made for really like other partner security systems to integrate with, or like enterprise databases and things like that. So the APIs were both esoteric, like there's like SSH-based APIs, a lot of those, things like that, and also very slow. Like the operations, the encryption operations and stuff were very, very slow. Manual installs, no downloadable software. That's really important from the practitioner-led bullet point. If your getting started experience is locked behind a form or an in-person certification or training or something, then it's sort of invalidated from the beginning. Like that'll work for selling to a business, but it doesn't work if the user is experimenting to adopt it. And that leads to enterprise targeted. A lot of the stuff was enterprise targeted. Cool, so we realized that none of the software around at the time really solved our challenge. We knew what we were looking for, and so then you build, right? And again, like the answer is no. You don't build quite yet. I think people skip this next step more often than they skip the previous one. The next thing that we do is design. And design is all-encompassing. It's not just like visual design. It's architectural design. It's user experience design. We design. It's like let's think of what are we going to build. We know what we want it to solve for. We know where we want it to fit it in. But like, how's it going to feel, and what's it going to do? How's it going to innovate? This is the most fun in my mind, because this is where I go from really crazy to starting to like figure out what's actually possible. What I always encourage even our employees today to do when they're in this phase of creation is write down what you would want, even if you think it's not technically possible. Just write it down, because maybe it is. And so I always do this, and I work from home. Hashicorp's a remote company, and my wife would always talk to me during creating new software. She's like, "Oh, how's your new project, whatever, going?" And I would always say like, "Oh, it's going to be awesome, but I don't know if it's going to work. But if it works, like as the paper says, it's going to be awesome." And that's the whole fun of design. So I break down design into 3 steps, and in this order. Step 1 is fixing properties of the existing solutions. Step 2 is inheriting necessary features of the category of software that you're building. And then step 3, which is the harder part, or the fun part though, is examining sort of your new environment for ways that you could innovate that predecessors were not able to for whatever reason. So step 1, fixing properties of existing solutions. This is super easy. You just take the list, the reasons why you didn't adopt someone else's software, and you flip them, and then you have the properties that you want to build. And again, you don't know if this is possible at this point. So single leader to highly available, for example. There might be a very important technical reason that every single other solution does not implement this as a distributed system. Maybe, but this is what we're going to try to do. So let's like tack that on as part of the design. And then you just sort of switch everything else, which I think is straightforward. Bad API to a standard API, manual to automated, go from non-downloadable software to our ethos is open source software, so that was obvious for us, but maybe not necessarily. But ours was open source software, downloadable without filling out a form, things like that, and targeting sort of the user rather than the enterprise first. And that makes it so we have to build less things too. We don't need to satisfy compliances or regulatory bodies or things like that, because that's not our target user initially. Step 2 is understanding the necessary properties of your category. So no matter what sort of software you're building, security software, infrastructure provisioning, password management, browsers, whatever software you're building, there are expected features that users will want. And you don't necessarily want to innovate those away, because then it's sort of, if you're too radical, then you're not adopted because you're weird, even if it's good software. So you want to be like, innovative enough, but not freak people out. And so you sort of inherit these necessary properties. And in the case of security, it's things like role-based access control. In other software, we shipped this in future updates. We didn't ship version 0.1 with access control. But for security software, if you ship version 0.1 without access control, it's pretty laughable. So we sort of made this list of stuff to inherit. And then finally, the fun step, the difficult step, but the step with creative freedom is examining the properties of the new environment which allows you to do something different. I think people look at software that they would say is bad software, that's popular though, that like is widespread, and they think it's just bad software. And I think that I instead think that like the fact that it's so widespread and used means it probably at one point was good software, but the reason it was bad was because it was made within the limitations and requirements of a certain time and didn't adapt, right? So I assume that people are generally like intelligent, and so the way I look at it is not let's fix the bad software, but like what do we have today that they didn't have the privilege of having that gives us an edge because we don't have a legacy to maintain. And so in this case, the properties that we were looking at were the properties of cloud. If we took a base assumption that everyone had cloud available to them, then what can we do that they couldn't do? So we took all these properties of cloud. We came up with a few things. I'm going to list a couple here. I'm only going to talk about one. But one of the things was dynamic secrets. The other was sort of using cloud identity as a way to automatically solve sort of the secret zero problem. But I want to talk about dynamic secrets just to use an example. We had this base assumption that everything would have an API. Most things have an API already, and everything will have an API in the future. If that's true, then we were like, what if the secret doesn't exist? Like, why are you creating the database credential? What if you didn't create the database credential and Vault created it for you when you needed it? And so every single web server that asks for access to the database would get their own user. And if you had that, then the audit trail could be tracked to a single machine, and you could revoke one user's access, and you could rotate across, slowly across the fleet, rather than having this mega password that's shared everywhere and managed by a human. And that was the general concept of a dynamic secret. It's not like the security systems before that, again, were dumb and didn't think about this. They may have thought about this, but it may have been impossible because 10 years ago, not nearly as many things had an API. And so by making this base assumption, we could do things like this. And so we came up with some new properties, and then we wrote this all down, made a design, and then maybe we build, and this time we actually build. You take all this and you start working, and something happens, question mark, and then profit. You have software that comes out the other side. The development part we could just skip because it's sort of straightforward at that point. You have a design. I think what's interesting is that it sounds very sort of waterfall-esque, and for new software and for new large features, a lot of our design process is waterfall-esque because that's not really iteration, right? It's initial creation, so there's a lot more upfront design work that happens to it. After we ship, it moves to a lot more of an agile, iterative environment. But yeah, I think we still have all the initial design documents. I think like the first design document for Terraform was, I think, 78 pages in a Google Doc. We write a lot of stuff at Hashicorp, and so all these initial things are a ridiculous amount of writing as we think about things, and they're usually like half wrong, but that makes it fun later. And so Vault 0.1, we went from having the thing to having a design to having the actual software, and in about 5 weeks. For Vault 0.1 took about 5 weeks, 2 people 5 weeks. And the features, you could look at it and like, what we aim for with a 0.1 is to sort of build in the innovative features that give people an idea of what we're heading towards, what we're trying to do. 0.1s are never really good software. They have major problems. They're not really well tested. They don't have as many features because you're trying to get something out. You're trying to balance getting something out with like working. And so you get it out, and you just sort of focus on the innovative features in order to give people an idea. And so the things that we did to set Vault apart immediately from other software was focus on this easy day zero experience. So I think this is taken for granted today. I don't think this is as innovative today, but in 2014, the idea that you could download Vault, run a command with a dev flag and have the server up and running completely, like no other dependencies, no other setups. You didn't have to run it you could run that on Mac, Windows, Linux, no VM or container necessary. Like the API worked at that point, was innovative. And so that was one thing we focused on, was we realized that the software is going to kind of struggle in a production environment. It's a 0.1. So let's make sure that the day zero experience is awesome for somebody. The JSON API was sadly innovative. Dynamic secrets, which I talked about. The idea of leases and revocation which is still there. The idea that every secret that Vault has, Vault is the only owner of any secret. You think you own the secret, but actually all you ever own when you use Vault is a lease to the secret. And if your leases expire, then Vault could do whatever it wants with the secret. It could revoke it, it could rotate it, it could do anything. And so Vault has a system where every client of Vault has to constantly renew leases and notify Vault it's still using a secret, at which point Vault could say okay, or it could say, okay, but I'm going to give you a new secret because we're rotating now. And this is sort of core to the system, which makes rotation very easy as you get farther along the adoption curve of Vault. The idea of end-person access for things generally was always available for enterprise solutions, but it being available in just like a downloadable open source project was pretty innovative. And so these sort of stick out. And what's fun about the innovative features is they tend to remain the main reason people adopt the software for, at this point, as long as we've been making the software. So the reason people still adopt like older software like Console and things like that, and even Vault now is 5 years old, the reason people adopt Vault today is really because of its extensive dynamic secret support and how core it is to the system. These things tend to be fairly long-lasting, so it's important to get these right. In addition to technical features, there's innovative philosophy. These ones are kind of annoying because you can't really iterate on these. I mean, you can, but they're usually beliefs, and beliefs are hard to change. So the features, if you're missing a feature or something, you build a new feature. If someone sort of disagrees with a philosophical design choice of the software, it's hard to reconcile that. One of you has to change your view, pretty much. And so the philosophies that Vault took are these. The first one is that it would be a single source for secrets. And if you tell this to a room of 100 people, 50 of them think this is obvious, and 50 of them think it's a terrible idea. It's a sort of splitting thing. But it's the idea that it's very, very, very difficult to do security exceptionally well. And so you should do it exceptionally well in one location rather than try to do it exceptionally well in n locations. So you actually do put all your secrets in one basket. You put all your passwords in one place. You put everything, all your API access to one place. And that way your security teams and your security practices can revolve around focusing on this one thing and watching it like a hawk versus trying to reproduce that. And so that's Vault's idea, is put everything into Vault and have a single cluster. You replicate that cluster, but you have a single sort of master cluster. The idea of human and machine access. So Vault has the ability to auth both using things like TLS certificates, but also using things like browser-based OAuth. And so it was the idea that everybody needs access to secrets, and applications are included in that everybody statement. And then the last one is practical security. And this one's, so if you ask somebody, is X secure? The response of yes doesn't really mean anything because the definition changes by each person. If you ask a startup, is your user information secured? They'll probably say yes, and that means that maybe they encrypt the database, right? If you ask that to a very large enterprise, that yes might mean that they have control access, audit logs, they have somebody watching the audit logs. There's a different level of expectation of security. And so what we found prior to Vault was that a lot of security software took a very hardline approach at defining what secure meant and said, you are not secure unless you do this. And for a lot of people, it was off-putting because you didn't require that much security in your environment. And so the idea with Vault is how can we give you enough security where it might not be secure to some people. You could have one unseal key. That's not a good idea at a certain stage, but if you're two people working on a new idea, like you don't have any users, you don't have any signups yet, like who cares? And so like, can you have sort of practical security, but have a system that scales with you so that you could ramp up security and change your definition of security and adapt the system to the point where you are one of like the largest companies in the world and it satisfies your needs. So that's a big thing. We'll get to, I guess, the negative feedback. But that's one of the elements of negative feedback that happens. So whenever there's sort of a creation moment, there's a lot of negative feedback. I tweeted about this years ago where there wasn't one thing that we made as an organization where someone told me I should not make it, right? Like there's always a reason not to make it. And with Vault, the feedback we got was sort of roughly in these categories as the most common things. The top one's really funny. People not a lot of people, but there are small amounts of people that have this very hyperbolic approach to things, which is like, oh, it doesn't do this, it's useless, like it shouldn't even exist, which is very intense. But it sort of ignores the fact that you could iterate on technical features. It's a neat concept of software. And so, missing feature X, that's fine. It's new software. We get there. We're working on it. Maybe it's not our target at the moment, our goal at the moment, but you could iterate and get there. There's no security background. Oh, yeah. So security, I don't know if it still has. I don't know. In my experience, when we first created Vault, security had an intense amount of gatekeeping surrounding it. So Armand and I were very self-conscious about sort of keeping it very secret, and now I'm more public about it, but keeping it very secret, that we had zero security background, right? Like, we took one undergraduate security class, we read some Wikipedia pages, sort of made sense conceptually to us. We read the source of some, how does OpenSSL do this algorithm, like basic things, but there was no formal background. And so a lot of people would attack us when they figured this out and say, there's no security background, how can you be trusted? Well, that's sort of a chicken and egg problem. There was one conference I went to where someone actually raised their hand in front of everybody, and I hope no one does this today. Actually, you'd be wrong today, so it's okay. And someone actually raised their hand and said, how many security PhDs do you have working on this project? It's like, what does that matter, actually? Like, I respect that a PhD has an immense amount of knowledge on something, much more than I do, but it's not a base requirement to be successful, right? Like, they have a higher chance, probably, but it's not a base requirement. And so there was a lot of security gatekeeping where people tried to convince you it was so complicated that only they were capable of doing it. But that's not really fair. And so there was that. There was, a lot of things that like, oh, this is cute, but because it doesn't, satisfy this regulation, it's not going to work. And some people that just said it's already a solved problem. So there's always this, and I think that part of creation is always having a sort of healthy amount of hubris. You need to have enough where people give you this negative feedback, and you're still have enough self-confidence that you're like, I accept your feedback, but I'm going to do it anyway. You can't have too much where you don't listen to it, though. Like I tend to think that people have a reason for saying what they're saying, and you just got to sort of ask why a few times to dig past the emotional aspects and the meanness and things to figure out the kernel of what they're actually trying to say, and find the construction feedback and react to it. So missing feature X, like, why do you need feature X? Do a lot of people need feature X? Like, should we build that next? Like, maybe we don't need it, but we're the special case. Like, maybe it's more common, so we should build it. Like, digging into this feedback is important. It's kind of hard when people are attacking you, but it's there. And then one of the things that we've always employed is something we've called internally. I don't know if there's a real name for this, but something we call the Submarine strategy. And the Submarine strategy, that we called it, is the idea like you consciously design software in a way that excludes certain groups of people on purpose because you don't want them to look at your software yet. It's sort of the idea that if someone touches something and hurts themselves, it takes a lot of convincing to try to get them to touch it again, right? But the first time convincing them to touch something is not that hard. So we want to avoid that first painful touch. And so there's groups of people that, for example, if there's a bug, if you're an early adopter and there's a bug, you report an issue. Maybe you actually read the source and try to fix it. If you're a late adopter and there's a bug, it's broken software, and you shouldn't recommend it to anybody, right? Like, there's a very different point of view. And there's superficial things that you could do that help sort of categorize these people. And so one of the ways that we did it is that our first releases of all our software never had a UI, never had a graphical interface, web or desktop or anything. Even when Hashicorp employed those people that were capable of doing that, we could have done that. But it was a conscious decision not to, because sort of stereotypically, but in our experience tends to be true, people who need a UI and aren't comfortable with a terminal are less patient about bugs. They expect things to work better. They expect that level of polish. Or if the UI looks good and the software doesn't work, they feel like they're being tricked, like false marketing and things like that. So we won't ship a UI. And what happens is that they don't get hurt, they actually just don't see it. It's invisible in plain sight. They don't even look at the software because it's not even an option to them. So they don't have a bad experience, they just don't know it exists. And that's what you want to do. And there's other things we want to do too. So the guides one's really funny because I've started actually putting these into a folder starting a few months ago. But basically on a weekly or bi-weekly basis, I get a tweet that says, you have the best documentation I've ever seen, and I get another tweet that says you have the worst documentation I've ever seen. And I've started putting them into folders, and I have about like 30 in each folder right now. And the reason is because they are self-categorizing right now into different types of learners and types of people and types of adopters. Because some people, you give them reference material, right, the machine assembly language guide, and they figure out how to build Doom, right? There's those people. And then there's other people that need Unity to build Doom. And it's fine. It's like I'm not judging them on either side. They just have different priorities and different requirements. That's okay, but that's what sort of happens here. All right, so now Vault exists, and I want to sort of fast forward into like, how's it doing today? This is sort of the superficial stuff, but I think a lot of people don't know Vault or aren't sort of aware of how adopted it is or things like that. And I think that is important too, because you don't want to build software that is a nice design that like nobody uses or you don't even find value in or something. So Vault today is pretty popular. I think something that's interesting is in the US, every single individual stock trade, a buy or a sell, every single one is signed by Vault. So if you participate in the US equities system, then you are interacting with Vault every day. Again, in the US, these are US skewed, but in the US, there's a cable provider that their set-top box on the TVs makes an API request to Vault every single day, and that works out to 70,000 API calls per second, roughly, at all times to Vault. And so that's pretty cool, and paying customers. So Vault is fairly well adopted, and I think we'll get to that, but why did Vault succeed? I think that Vault solved a real problem. It solved a problem that I was facing myself, so we sort of felt we understood whether we had solved it or not without talking to too many people. It fit into a modern environment. We sort of skated to where the puck was going rather than where it was, right? We chose cloud even though it was not very well adopted in the enterprise space, but the enterprise got there. And by the time they got there, Vault was the most mature sort of solution for them, which was nice. It innovated in certain ways, but I think what's really key here is that it innovates less than you think. If you look at the set of features that Vault does that are truly different compared to competitors or predecessors, it's maybe like 1 or 2 or 3 things. It's not that many. It innovates less than you think. It's all about sort of fitting the environment. Making friends is really important. One of the reasons Vault and Terraform, for example, are so popular is that we actively work with people like cloud providers and with companies like Datadog and GitHub and so on to try to get them to participate in the community to have integrations and things like that. Because a lot of times choosing the software isn't just like, does it check the box? It's about, does it work with the other software that I use? And so I think this is a really, really big aspect. And then there's a lot of the non-technical machinery around it that's very important. So that is that. I think the key point around this, right, is that Vault was an act of creation, and everything is around you, and understanding why that happened, understanding that I didn't have any formal background in security. There's no reason that my co-founder and I should have successfully created something like Vault, and yet we were still able to. And so just understanding the problem, following the steps, and caring about solving it is possible to sort of do whatever you'd like to do. So thank you very much, and hope that was interesting.